Okay, I am at home because my son is puking. So this has been a week for my family, multiple kids being sick. Um, just because I'm out doesn't mean that we're not doing learning. And this stuff is going to go in the grade book here pretty soon. So you need to stay on track, stay focused here in engineering math. Remember, it says pre-calculus, but that's engineering math. So a couple of things. First thing, I'm just going to start off with the items you need to grab for today. So first of all, up on the table next to my desk, you'll find this stack of notebooks. Pick the one you want. And then on the front cover, I want you to, in bold, like big bold words, your name and math in engineering. That's what it's being recorded as in Airtable. It's not in the transcript that way, but that's what it is in Airtable. So we're going to say math in engineering for this course. I've got some thing of Sharpies. Please put them back. Students have stolen all the like black and dark blue ones. So please put them back. So, but big and bold, make sure so when I'm handing them out, it's easy and fast for me to see your name and hand it out to you. Okay, so that's number one. Okay. Number two is that you're going to actually use those notes today. And so you're going to need, I'm getting it from the print shop this morning. It's going to look something like this. Okay, you're going to need this stack. It'll also be on the table right next to all those notebooks. And there's going to be some notes to take as I show you in this video. You're going to also need, not necessarily to start, but pretty soon, you're going to need this again. I've set it up for today so you can just pull it out of the cabinet and grab a power supply. Again, make sure it's 15 volts, center positive. Plug it in, it should be ready and set up. I'm just going to quickly show you what it should do when you turn it on. Okay, so turn it on. You're going to turn on the oscilloscope, and when you press one of these buttons over here, you should actually, I just realized this one's not set up. Do real quick. There we go. You should get a sine wave to show up there. Let me slow that one down here. Yeah, some sort of sine wave should show up on the side. That's what should, no sound, that kind of thing. You don't need headphones today. I don't want you pulling out any other equipment than this. And when you're done with this, I want you to neatly put it back. So we're going to make sure that none of this equipment is out while I'm not here with the freshman geometry classes, because you took it out and you put it back at the end when you were done with it. Okay? And then, oh, there's one more thing that will help you in the exercise here. You don't have to do this, but man, does this help a lot. If you are in the oscilloscope mode, again, if you're in this menu, all you have to do is click the white knob on oscilloscope. Okay? And then if you go to trigger, or trig, and it's mode auto right now, if you turn it to norm, which stands for normalize, then I'll show you the difference between those two. So here's auto, and then when I normalize it, it tries to freeze the waveform so that as I move it around, I can see the waveform without it like jumping around on me. So here's what it would look like under auto. So you can see it's like moving around. Anyway, so it's just trying to normalize that so that it kind of freezes it for you. It's easier for today's investigation. There's lots of investigations where that's not good enough. We need to have a fuller picture, but today, that's good enough. I also want to note that when you're doing the exercise, it'll ask you to turn the range and tune knobs like we've done before. But if this blue wire goes down here because I determined that this top one doesn't work well enough, then you have to turn these two silver knobs. Okay? So that's just when you get to that step. That's not the very first thing, but it is early. Again, when you're done with that step, put it back. Turn it off. Neatly put it back. Okay. All right. Moving on. Here is where you're going to start. Now this, I have to go to the print shop to get the ones with like a nice cover and stuff, but this is from previous things, so I want to show you what you're going to do. First, this section is a review of an idea from geometry. It's called just trigonometry, part of geometry, sine, cosine, and tangent. So this is an opportunity for you to practice those skills that you may not have used for a while. I'm going to do a quick review, overview of those basic skills that you need for today. But I'm going to challenge you to do this whole sheet, to actually figure out how to do it for two reasons. Number one, you need the practice again. Number two is that when you are an engineer, like there are times when you go to solve a problem that you haven't solved in 3 years or 10 years, and you have to look up. Like I remember learning how to do that thing, but I've forgotten. And so you have to look up those details and figure it out. That's just the process of being an engineer. And so when it comes to some of these things, if you get stuck, like it's on you to figure it out, not just necessarily just like you figure it out solo, but like ask a classmate, do a Google search, go to Khan Academy and type in, SOHCAHTOA or sine, cosine, tangent, those kind of things. Find those resources. They are available to help you solve those types of problems. But I'm going to give you the basic introduction right now. This is something that you can put in your notes now that you have your own notebook. Okay. So first of all, when we're talking about right triangles, so they have to have like a right triangle symbol. This only applies to right triangles. We have this acronym SOHCAHTOA, which stands for sine is equal to opposite over hypotenuse. So here's sine of an angle is opposite of hypotenuse. Cosine is adjacent over hypotenuse. Cosine is adjacent. Tangent is opposite over adjacent. And I'm going to zoom in here. I want you to note that this right here, this symbol, if you haven't seen it before, is a Greek letter theta. So I'd read this as sine of theta is what I would say when I saw that. Okay, cosine of theta, tangent of theta. Don't say cos or sin. That's not how they're pronounced. Okay, or tan. It's sine, cosine, tangent. But that's just a symbol that typically represents some sort of rotation or angle. And so that's why you'll see it used a lot in this course, is that within the sphere of physics and engineering, it's often used to represent rotation or an angle. So there you go. So it's the sine of some angle is equal to the ratio of two sides in a triangle. So now I need to remind you how that works. Okay, so down here, I have an angle right here. We're going to call this angle right here my reference angle. And compared to this angle, the opposite side is across from it. And so this is the opposite side. Okay. The hypotenuse in any right triangle is the longest side. You can also tell it's the longest side because it's across from the 90-degree angle. The 90-degree angle will be the largest angle, so it's across from that. Which leaves only one left, and that's our adjacent side. Adjacent means next to. It's the one next to the angle. There's actually two next to the angle, but this one's a hypotenuse. It's the longest side. So if I go here, I look at the same thing. Down here is my hypotenuse. It's the longest. It's across from the right angle. Okay, here's my angle, so that means this is my opposite, across from it. And then right here is my adjacent. So your first step is just being able to identify what are the opposite hypotenuse adjacent sides. And I often go in that order. What's opposite, what's the hypotenuse, and then the leftover one is the adjacent. Once you have that, you can write equations based on here. So the sine of the angle is the opposite of hypotenuse. So here, my angle is 67. So if I go sine of 67 degrees, it's equal to the opposite over the hypotenuse. Well, that's 12 over 13. And then I can write another equation. The cosine of that angle is equal to the adjacent over hypotenuse. So adjacent is x over the hypotenuse is 13. And then the last one is tangent. The tangent of 67 degrees is equal to opposite over adjacent, or 12 over x. And you don't have to write out all these equations every time. What you're often doing is writing the equation you need. So I wouldn't necessarily write this equation because all the numbers in here I know, but I might write this one or this one if I'm trying to find out what x is. So same thing over here. If I'm going to go over here and write an equation, I need to pick the one. I could write out all of them, but I could also just pick one that's going to work. And in this case, because I know everything, I could just pick any one. But say I didn't know that, I just knew those. Well, then I would look and go, well, I know the opposite, I know the adjacent, well, that's tangent, okay? Over here, if I didn't know this one, sorry, actually, let's do it this way. If I didn't know this one, then I would go, okay, I know the angle, I know the hypotenuse, but I don't know the adjacent. So that's what I want to know, though. That's what I want to know. So key, it needs to be in there. I can't solve it unless I have the adjacent in there. So I have the adjacent, the hypotenuse. Okay, so then I go back. And so adjacent hypotenuse, that's cosine is what I'm going to use. Here, if I was doing it this way and I had opposite adjacent, I was trying to find out the angle, then I'd be using tangent. So let's write that there. Tangent of the unknown angle is 6 opposite over 8. Okay. So you can write out all the equations if you want to, but really you only need to write the one that helps you solve the problem you're trying to solve. Okay, and that's your review here for that. That should be able to get you through this. Again, you're trying to figure this out best you can, work together. Don't try to do any of this solo. Always have a partner or a group that you're working with. Okay. And then you can pause the video here and do this. So please pause. I'll wait. Okay, I'm assuming you've now resumed the video and that you've finished this section. If not, you should still pause. Okay. Now, this next section is when you'll need to pull out this module over here. But it is written for the past. So it says the cells module. And it might still be in there, or it has this device that we've been using where it's got the little keypad on it, but you just press one of those, and this guides you through it. Please read every word. This isn't a textbook. This is my own handwriting that I wrote for you to help guide your learning. Some of this stuff is going to be like, oh, we've talked about that a little bit, but this is a guided thing for you to be able to go through it with a partner or with a group and be able to have this conversation as you go along. When there are things that say discuss, you can write down little notes for yourself, but I don't provide a lot of space because I want it to be a discussion. You cannot do a discussion with one person by yourself. You have to have a second person with you, doing it with you. So as you go through this, make sure you have that. It does say now you may put on the headphones. I'm going to ask you to just switch the speaker on, just so that we don't have the clutter of the headphones to have to put away as well. They won't be on for long, and just keep the volume to minimum and don't be annoying. Fair enough. Okay, down. Now, when you get to this side, this link right here, it goes to a link that is now blocked on student laptops. So my workaround is that this link up here, and make sure you capitalize the H and the S, goes to a zip file that you need to download. It's in the upper left corner, the download button when you go to the link. You need to then, it should open up. It's a zip file. You should open it up and make sure you click extract all. I should write the word all there. So you extract all. And when you do that, it'll open up a folder that will now be like unzipped. And then you can open the HTML, or I think it even is just the HTML page. Okay, it's the file that is like launches a version of the website that isn't on the web; it's on your computer, and so that's the way to get the web app to work. Otherwise, you would have to, hotspot your cell phone or something like that for this link to work. Okay. So yeah, you do that, and it'll work great. Okay, help each other, get around that technical hurdle. Then you're going to walk through this process. Down here, it says teacher checkpoint. Now, normally I tell you, and I'm not here, you can't go past a teacher checkpoint. You have to do a teacher checkpoint before you move forward. We're going to collectively do this teacher checkpoint on Monday when I'm hopefully back. Hopefully all my kids are done being sick. Okay? And then over here, but today, if you get to that teacher checkpoint, you can continue forward. And this will guide you through a process. Make sure, again, you read every word and you work together to move through it. And then I want to let you know one last thing is that when you get to this page, by the way, if you get all the way to this teacher checkpoint, like gold star, that's amazing. When you get to this page, it says find the unit circle in Schoology. We don't have Schoology anymore. So here's a link. I didn't actually create this link. This already exists. And when you go there, it will look like this. And so there's some Arabic script on there, but it's a unit circle, and you can like scroll in and out to like zoom in and out. And these are all the components that we need for that exercise. Okay. And I'm just going to do a quick thing here where if you see here where it says the sine of 90 degrees equals 1 and the cosine of 90 degrees equals 0 as an example, where they get that from is up here. It'll say, wow, is this not in degrees? This is not in degrees. Oh no. Okay, usually the unit circle is written at 90 degrees. Okay, so I'll have to explain this here right now. This right here is 0 degrees, and then you go up, and this next one is 30 degrees, then 45 degrees, then 60 degrees, then 90 degrees. If you want to see a unit circle that has degrees written in it, just do a Google search, an image search for a unit circle, and you'll find one. It'll be really easy. But this is 90 degrees for the sake of just making this video shorter. That's 90 degrees. And if you go up there, there's a coordinate written up there. This is how all unit circles work. And man, even if I zoom in, it doesn't get any bigger. It says 0, 1. 0, 1. So the 0 is what the cosine is. It's the first thing listed is the cosine, and the second thing listed is the sine. And so that'll help you kind of like work through the process. When you use a unit circle, the cosine is always the x-coordinate, the sine is always the y-coordinate. And help each other out. That's it. You can go past the first teacher checkpoint. We'll do that on Monday, but do not go past the second, because I want to make sure that we clear things up and you understand how grading works on this stuff before you move past that, because I don't want you to harm your grade or your own learning. And that's it. I'll see you on Monday. Come on. There we go.